equations. All right, we never talk about the expression. We don't use the word solve. We can only simplify. We can simplify an expression. We try to solve equations. Sometimes we want to label statements with letters. Let's see, this whole statement, if an integer x is a multiple of 6, then x is even. You know, we may call this whole statement P. So P represents this whole statement. Then we will give a conclusion to say, okay, the statement P is true. Because if a number is a multiple of 6, of course it's an even number, right? Because 6 is an even number. The sentence, the integer x is even, is not a statement, right? Because we don't know x. We don't know if this statement is true or false. Because x is a non-variable. Right? X is a non-variable. Because for some x, this is true, right? If x is an even number, the statement will be true. But if x is odd number, the statement will be false. So we wouldn't call this a statement. So in the realm of talking about sets, all right, we don't consider this one as a statement. A statement has to be either true or false for this class, for this course. And what do we call it? We call it open sentence. Okay, open sentence. It has a variable x in it. So it can be true, it can be false. It depends on the value of x. And we call open sentence. Okay, let's see now. We have statements we can do and, or not. We can use those three almost like a commands in the statements. So let's see, we have two statements, P and Q. Right? We don't know what P is, we don't know what Q is, but we know P and Q are two statements. Either P is true or false, or Q is true or false. And we can combine them with the word and. So let's see. Let's see an example. P is a statement, the number 2 is even, which is a true statement. Right? Let's see Q. The number 3 is odd, also true. So P and Q, both true statements. Then we say P and the Q. The number 2 is even and the number 3 is odd. So we can use and combine those two statements. And we use a notation. We use a notation like this, like the upward arrow. We use this to represent the P and the Q. P and the Q. Okay, the statement P and the Q is true if both statements are true separately. So this relationship, you know, we call it true table. In the true table, okay. And so why we want to use P, Q to represent a statement? So we can make a table like this. You know, this is part of logic in mathematics. So we see P and Q, right? P can be true. So in general, P is a statement can be true and false. Q is a statement can be true and false. And if P is true, Q also true, and the P and the Q is true. If P is true, Q is false, then P and the Q will be false because it's combined to be like one statement would be false. If P is false, Q is true, then also P and the Q is false. If both are false, then P and the Q are false. Right? So this is like, you know, as long as only when both is true, P and the Q, the and statement will be true. Either one is false or both are false, then the and is false. Similarly, we can combine two statements P and Q with or. Okay, let's see the truth table. We call this truth table. We can give a name here. So we call that truth table. I want to highlight this. So we call those two tables truth table. So let's see the or truth table. So this one is and, the top one is and, this bottom one is or. So or, we use this notation, this downward arrow. We use this notation, P or Q. Okay, so P can be true or false. Q can be true or false. Let's say P or Q. So you both true, P or Q true. If one of them is false, P or Q still true. Only when both are false, then P or Q is false. You see, this is almost, right? True. So this is P, this is and, or command. So right at this point, just think and, or, and not, like a commands of those statements. It's a little bit different from, the literal meaning of and or. Let's see these comments. Give any statement P, we can form statements not P. Okay, we consider not as another command. So not P, basically we negate the whole statement. Or it's not true that P. Denote as this, we use this symbol. You see, we use this symbol, not P. Let's say P, let's see an example. So let's say P is a statement, the number 2 is even, which is a true statement. So not P will be negation of P. It's to say it's not true that the number 2 is even, right? So it makes the whole sentence false. Or to say the number 2 is not even, right? Make it so it was a true statement. Now we negate, it becomes a false statement. Not P, or we can say it is false that the number 2 is even. It is not true that the number 2 is even, right? It's a similar, right? It is a negate. Negate the true. When we negate the true statement, it becomes false. When we negate the false statement, it becomes true. So if P is true, not P is false, right? If P is true, is false, not P is true. So that's this truth table. The truth table is this, P, not P. If P is true, then not P false. If P is false, not P is true. All right, truth table. Okay, any questions so far? So we have to remember a bunch of commands and notations, associate with them. Okay, let's see conditional statements. So now we know statements, right? Some statements are conditional. We use if and then. We say if and then in the statement. Let's say P is a statement, the integer A is a multiple of 6. And the statement Q is the integer A is divisible by 2. So conditional statement, we can make if P. So let's say R statement, right? So we use P and Q, make another statement, R. If P, I was trying to highlight this. Does not allow me to highlight. So we say R, if P, then Q, right? If the integer A is multiple of 6, then the integer A is divisible by 2, which is true, right? Or we can say if the integer A is a multiple of 6, then A is divisible by 2. So this is the if-then statement, conditional statements. So the statement if P then Q, or P implies Q, we use this notation. We use this arrow notation. So P implies Q. which means if P, then Q. If P, then Q. So P implies Q. And it is a conditional statement. So the corresponding truth table is this. Well, P, we have Q, have two statements. So P implies Q, or if P, then Q have these truth values. So if P is true, Q is true, then P implies Q is true. If P is true, Q is false, then P implies Q will be false. If P is false, Q is true, then P implies Q will be true. Because why? Because Q stands alone, does not depend on F, depend on P. Because Q is true anyway. So if P, we see this too. If P is true, Q is true. If P is false, Q also true, then P implies Q is also true. Because this feels a little bit weird, but if you think of it, Q is true all alone, right? It does not depend on P. So P implies Q is true. And then if P is false, Q is false, P implies Q is also true, right? So this logic may, we may feel a little bit weird in the beginning, but if we do a couple of examples, we'll get used to this. Let's see an example. So let's say R is made of P and Q, right? P is if you wear a red shirt, then you get $1, right? So let's see if this is P, the first sentence is P, and the second sentence is a Q. Okay, so this is a conditional statement. The statement is saying, if you wear a red shirt today, you get $1. All right, so let's see that if indeed you are wearing a red shirt, right, and you get $1 according to this R, according to this conditional statement. If you're wearing a red shirt and you don't get $1, then the statement R is false, right? Because Q is being negated, because Q is false, right? Because Q is you don't get $1, it's not Q. Because think about the P is you wear a red shirt. P is wear a red shirt, and Q is get $1, and so R is P implies Q. So if P is true but Q is false, that means R is false. The truth table, the second one on the truth table. Then if you are not wearing a red shirt, you still get $1, and the statement is still true. That's the third one, because you get $1 anyway. That's this one, right? The third one on the truth table, right? If you're not P, if you're not wearing a red shirt, but you still get $1, so the statement R is still true because you get $1 anyway. Then the last one, if you are not wearing a red shirt and you do not get $1, right? This is not P and not Q. So the statement R is true, still true. Because we negate P, we negate Q, and we negate R. Any questions? Conditional statements need a little bit of time to digest. Okay, lastly, we have these biconditional statements. If P implies Q, remember P implies Q, if P then Q. If P implies Q is true, does not necessarily mean that Q implies P, right? Not the control not the reverse, right? Not the reverse. Let's see this sentence. If you get $1, that means you're wearing a red, which is not true, right? Because it depends on this one, the third one on the truth table. You get $1, you get $1, right? It does not depend on you're wearing a shirt or not. Depends on the sentence R. So P implies Q does not go the reverse way. Doesn't mean Q implies P. It's true. If you are wearing a red shirt, you get $1. Does not mean the same as if you get $1, then you are wearing a red shirt, right? You get $1, you get $1, right? The conditional statement Q implies P is called the converse. All right, it's called the converse of P imply Q. So Q implies P is the converse of P imply Q. Also, P imply Q is the converse of Q implies P. So they're converse with each other. We use this term, converse. Sometimes both a statement and its converse are true. Well, let's see this one. A is even implies A is divisible by 2, right? The two statements basically, right, basically the same, because even means the number can be divided by 2. A is divisible by 2, and A is even. Okay, sorry, this is typo. A is divisible by 2. It's missing by 2. A is divisible by 2 implies A is even. Right? If both the statement and its converse, anyone has any questions? If both statement and its converse is true, this means P implies Q and, you see how we use and Q implies P. So we use a shorthand notation. We use this, right? So P implies Q, Q implies P. We use the two-sided arrow to represent that. And we use the word if and only if. Okay, P if and only if Q. Okay, sorry, this is another typo. P if and only if, or Q if and only if P, or P if and only if Q. You can understand this as an equal sign, but this is equal in statements. So we use different notations. So the corresponding truth table is this. So P and Q, P implies Q, Q implies P. P if and only if Q. In mathematics, when we do proofs, we're always trying to prove one way and its converse. So that's if and only if. So that means it works for both ways. We can go from P to Q, also we can go from Q to P. So P implies, if P is true, Q is true statements, then P implies Q, Q implies P, that's true. So if both true, and if and only if true. If both false, if and only if true. Okay, if P is false, Q is false, then P implies Q. And then also Q implies P, so which is also true. So P if and only if Q is true. But as long as one of them is false, so this is not, this is false. Okay, the if and only if relationship does not hold. Okay, let's try. Anybody has any questions? So this logical stuff sometimes could be confusing. Let's try some exercise. Let's put this into our classwork. Okay, let's try one, and you may type your answer in the chat. Patrick, can you hear me? What do you mean, any audio? Oh, okay, you can.
Sorry.
It's okay. You can either type in the chat or just speak out. So let's try the first one. Okay, yes, yes, yes. All right, so I have 15 of you. I'm still missing 2 students today. Okay, pretty obvious, right? Right? Okay, so which of the following are statements? So 1A, yes. B, is B a statement? No, right, good. C, a Thursday is a month. Is a C a statement? Yes, it's a false statement, right? A is a true statement. B is just an expression. It's not a statement because it cannot be true, cannot be false. And C is a statement. It's a false statement. D, every polynomial of degree n has at the most n roots. Is this a statement? Yes. It's a true statement or false statements? True statements, yes. At the most n roots. E, 3 is an even number. Is a statement? Yes. But it's a false statement, right? Because 3 is not an even number. It's a false, but it's still a statement. It's a false statement. What about F? Multiple of 6. Not a statement, right? Not a statement. It's just an expression. Okay, G, the integer x is a multiple of 7. Is this a statement? Is a statement? Is a statement? Well, Aliyah is saying false statement. What about x is 14? Can x be 14? If x is 14, the integer 14 is a multiple of 7, which is true. But what if x is 13? The integer x, the integer of 13 is a multiple of 7. That would be false statement. So this sentence can be true or can be false. And we have a term for it. Anybody remember? Open sentence. Great. Right. So this kind of, it's not statement, but it looks like a statement we call open sentence. Because x can be any number, right? So it can be a true statement, it can be a false statement. We call open sentence. Okay, great. Now let's try 2. So I'm going to call people on this. I'm going to just follow the list, all right? So 2A, the number A is both even and the power of 2. Okay, I done. Is this a statement? Oh no, with each, so we know this is statements. So we want to do P and Q, P or Q, and not P. Okay, and read P and Q. So you know what? Maybe I give you some time. I give you 5 minutes for number 2. So A, B, C, D. All right, so you can, because this take a little time. Yeah. Call the first statement P, call the second statement Q, then try to figure out P and Q, P or Q, and not P. And make sure you don't have to type, this is too much to type in. So I'm going to ask you, you can answer me through the audio, okay? Then if you're ready, we'll start with you for A. Your A means and, right? P and Q. Okay, yes. Right, so A is P and Q. You also answer for B. B is or, P or Q. Good job. Yeah. And C. C. Okay, good. Not sure. That's good. That's okay. Ajaya. I probably see your name wrong. Ajaiah. You have to teach me how to pronounce your name right. Yeah. So what it is? So we're at C. So C, the function f is not a polynomial. So it's a P or Q, P and Q, not P, not Q. Which one? Not P, right? The function is not, which one the function f is not a polynomial, right? Or not P. All right. D, x is in A minus B. What is this? Let's see. Ashrat, ISHRAT. I was trying to just to follow the attendees on the sidebar. ISHRAT. Okay, so D. Right, what is your answer for D? Not P. You mean not P? Okay, so figure out your P, your Q. What do you mean by not P? Right, this one is quite challenging, right? P and Q. So this P and Q. If it's P and Q, we have to have. Right, if it's P and Q, that means something P. We have two statements. Right, let's try to figure out. Let's try to figure out, is this a statement? D. No, it's not a statement. So what is it? Expression. Well, let's move to this one. Let's move to. Remember G? Do you remember G? The integer x is a multiple of 7. Remember what do we call this? Open sentence, right?
Open sentence.
Yeah. Right. It's a similar problem. You see x is in A minus B, right? We have no idea what that is. Okay, let's see 3. 3, we want to convert following statements into the format P implies Q. Remember this notation, P implies Q, means if P, then Q. And we have to follow the truth table, right? If P is true, Q is true, then P implies Q is true. If P is true, Q is false, then P implies Q is false. If P is false, Q is true, P implies Q is still true. If P is false, Q is false, P implies Q is true. I will have to follow the truth table. So let's try to convert this into P implies Q. So I'll give you a couple minutes to do this. Figure out the condition one, right? This is called a conditional statement. Which statement is a conditional? Gives a condition. Any questions? Okay, Jinqi already give an answer. Jinqi is saying P implies Q. P is a statement integer divisible by 8. An integer is divisible by 8 only if it is divisible by 4. So you are saying if let's convert your P implies Q. Let's try to use the if, right? Remember, P implies Q means P if P then Q. You were saying that's P. That's both direction. No, let's try to do one direction only for this. So we only want to do P implies Q. All you have to do is switch your P and Q, right? Because if it's divisible by 4, so we want to divisible by 4 to be P. And by the way you are writing it, P is integer divisible by 8, that will be Q, right? And divisible by 4 will be P, because the sentence is saying if it's divisible by 4, then it's divisible by 8. Let's see, P, Q implies P, right? In your case, you write as P implies P. But however, you see 3, the instruction asks us to do P implies Q. All right, so we have to follow the instruction. The instruction wants us to do P implies Q. Okay, Patrick is saying P is if it's divisible by 4, then it's divisible by 8, right? If divisible by if it's divisible by 4, then it's divisible by 8. Oh, P implies Q, right? We just how to write. Adam is asking how would we write the answer? So we would write P, just like writing in the chat. Adam, do you see people writing in the chat, Patrick and Jinqi? So P equals, especially for Jinqi's, just switch Jinqi's P and Q. She's saying Q equals to integer divisible by 8, and P equals to divisible by 4, right? P implies Q, right? That's what right, we just want to convert. At this moment, we don't care if it's true or, if the statement is true or false. We don't care about that. We just want to convert the combined statements into P implies Q form. Okay, let's try B. B, a function is rational if it is a polynomial. So which part is if? Which part is then? Let's see. Maya is saying P equals to, it's a polynomial. Q equals to function is rational. Yes, I agree with you. Jinqi has Jinqi, Jinqi, think about it. Look at the sentence. A function is rational, right? That's like a then part, right? That's like a conclusion. Which part is a condition? The condition is on if it is a polynomial. Because P implies Q means if P, then Q. But by your writing, that's if a function is rational, then it's a polynomial because P implies Q. Okay, good. All right, C, let me call someone. C, Maria, you want to try C? Okay, by the way, Maria, I didn't see your homework too.
Yeah, I need to talk to you about that. I think maybe like after class I can shoot you an email. Okay,
all right. Sometimes if your life is too busy, you may skip one homework, right? Because you just wouldn't get a full credit. Because later this afternoon, I'm going to post the solutions of homework 2. By then, I don't.
I already have half of it done. I just need like an extra 10 minutes after class to get the rest of it.
Oh, I see. Okay, all right. Okay. All right, Maria, do you like to try C? For function to be defined at a point, it is sufficient that it's continuous. How do we transform this into P implies Q? If P, then Q form. So which part is P? Which part is Q? P is, if it's continuous, yes, right? P equals to, if the function is continuous, then Q is defined, then is defined at a point. So that's P implies Q. Great. Yes, I agree with you. Great.
I wasn't sure what the sufficient part meant in C. Like, do I need to include that in my definition of P?
That's just English, that's just English. But let's try to the logic. You get the logic.
Yes.
Are we trying to get the logic from the sentence? We don't care about if it's sufficient. It is sufficient. It just means if, right? The if a condition satisfied, then something happen.
All right.
Okay. Good job. Okay, D. Let's see, Michael. Michael, you want to try D? Okay, D. You fail only if you stop writing. Right. So which one is P? Which part is P? Which part is Q? Michael, you like to try it? Or you need help? Okay, Moises, can you help? Oh, Aidan is helping you. Aidan is saying P equals to stop writing. Q equals to failure. Yes, right? So P equals to if you stop writing. If P, then Q, right? The Q means you stop writing. Q equals to you fail. All right. Now let's go for P implies Q. Right, we're still doing P implies Q. Now let's go to 4. 4, convert the following statements into format P if and only if Q. That means we can go both directions. If P, then Q. If Q, then P. Okay, so this notation means P if and only if Q. Okay, So logic is useful for mathematical proofs. All right. So I'll give you a couple minutes. Then I'm going to call people. In this case, it does not really matter, Jinqi, because this is almost like an equal sign. If P, if and only if Q, that's the same as Q, if and only if P. So both directions. Okay. Okay, 4A, Moises. Moises, are you here? Okay, so Moises has P if and only if Q. So he called P equals to if pigs fly. What? Moises, 4A, please. If pigs fly, then you'll be rich as you'll be richer than Bill Gates.
Sorry, I wrote the other one. I wrote the additional problem.
Oh, I see. You're ahead of us. Well, would you please try to answer 4A? By the way, the goal of our life is not to get rich, right? I mean, it's good to be rich, but okay, anyway.
Yeah, I think on that one I got stuck.
You got stuck? Okay, let's get someone help you. My, MYVU. Okay, so my is saying P is XY equals 0. Q is X equals 0, Y equals 0. Right. That's great. You see that, Moises? Does that work for you?
Yeah.
X, Y equals 0 if and only if X equals to 0 or Y equals to 0. And even your short notation is right, but hopefully everybody can be precise. Okay, so later on you're going to do mathematical proofs. It has to be precise, no holes, no bugs. Okay, any mathematical proof has to be so tight, so very tight. Okay, there's no any tiny bug in it. All right, and I don't see your homework. So you missed 2 homeworks. So that means you missed 20% of your homework credits. Okay. Let's see, B. Mayat. The angle measure 90 is P, if and only if it's Q. Right. The angle is right. The angle is right is P. Right. It measures 90 is Q. Okay, very good, great. The order doesn't matter, right? Yes, because only in this case, only in if and only if case, okay, the order does not matter. Okay. C, Lino, 4C. To get an A is necessary and sufficient. Necessary and sufficient. We, sometimes we always use this necessary and sufficient condition for proofs for your average to be above 90%. Okay, is saying P is getting an A, Q is average is above 90%. Great, right? To get an A, if and only if your average is above 90. You know, necessary and sufficient is another way saying if and only if, right? So necessary and sufficient is another way saying if and only if. You will see this, you know, many mathematical proofs have this kind of, use this kind of sentences. Okay, additional problems. First one, write each of the following as P and Q, P or Q, not P, P implies Q, or P if and only if Q. All right, I'm going to keep calling. Patrick, 1A. Oh, someone, oh, Moises was trying to do this one. Patrick?
Yeah, if pigs fly is P,
Okay.
P then Q, so Q is I am richer than Bill Gates.
That's P
then
implies Q, right? You're doing P implies Q there.
Yeah, the P, if P then Q.
All right. Okay, thank you, Patrick.
Okay.
1A, P and Q. No, the first one is this one, right? It's a P if P implies Q. Right? That makes sense? If so P is pigs fly. And Q is I'm rich than Bill Gates. That's Q, right? If P, then Q. All right. Samisha? Aida is asking if and only if? No. A is not if and only if, right? 1A is if P, then Q. It's a P implies Q form. Then does that make sense? You see, we don't see if and only if, right? I'm sorry, right, Samisha, because Aidan has a question, so I'm trying to answer his questions. Okay, Aidan, let's see. Let's see this one. If pigs fly, then I'm richer than Bill Gates. Do you see that clearly? P implies Q form. There's no if and only if. If we put a if we change this one, if and only if, that would be pigs fly if only if I'm richer than Bill Gates. Does that make sense to you? But here we only have if pigs fly, if P, then I'm richer than Bill Gates, then Q. So that's a P implies Q form. Okay. 1, 2, 3, 4. 4, right? Let me see if I can highlight this. Sometimes my computer does not allow me to highlight. Oh, here, I can highlight. Do you see this? P implies Q. Okay, Shamisha. Where are we? 1B, right? It is a hot and a sunny day. So how do we write a shorthand with PQ? And which one it is? The first one, P and Q. Okay, let's try to remember them. The upward means P and Q because we see and, right? P is, it is hot. Then and, Q is a sunny day, sunny today. Okay, great. And okay, Samuel 1C. Today is not Friday. Samuel, are you here? All right, Xiaomin. Xiaomi, so which one is the 1C? Not P. So P is today is Friday. So today is not Friday, that's not P. And P is today is Friday. All right. Now let's go second round. So D, Aidan, you want to try this? We're going second round now. X minus 1 equals to 0 is a necessary and sufficient condition for X equals to 1. P implies Q only? What does necessary and sufficient mean? Necessary and sufficient. Necessary and sufficient means if and only if, yes. So Aidan, how do we change your answer? Great, yes. So with both arrows, so P if only if Q. So P would be X minus 1 equals to 0. Q would be X equals to 1. So those two equations are exactly the same, right? All right, good. Now E, 1E. Ajaiah, A-J-A-I-A-H. If I see your name wrong, let me know. So 1E is X in, X belongs to, or X is in the set A union B. Ajaiah, are you here? Oh, yes, okay. So what is your answer for 1E? It's a tricky one. Okay, E is a tricky one. E is none of them, right? We cannot use any of them to write E, right? Because E, again, is an open sentence. All right, Ajay, I'll let you try 2A. So E, we cannot use, neither of them we can write as E. E is just open sentence, okay. Let's try 2. So 2, P is a statement. The statement is 4 is greater than 6, which is a false statement. Q is 1 plus 1 equals 2, which is a true statement. R is another statement, 1 plus 1 equals 3, which is a false statement. So we have 3 statements here. So what is the true value of the following? So we want to use the truth table to figure out this. Okay, Ajay, you want to try 2A? False. Okay, so P is false. So P and Q. So even Q is true, but P and Q is false. Great. Okay, abstract 2B. ISHRA. Probably see your name wrong. Are you here? Yeah, if I call your name wrong, let me know, please. Oh, okay. Do you want to try 2B or you need help? Okay, false. Let's check. So P is false, Q is true, and P or Q is true, right? It's right. Do you see why it's true? If it's a P and Q, that would be false. But a P or Q means as long as one of them is true, and P or Q is true. Do you see the mistake you made? Oh, okay. All right. Great. And so 2C 近期 2C, we have a P 2C. You want to try 2C? P and not Q. P and not Q. False. You've seen false. Okay, let's the rest of you. Do you agree with her or you do not agree with her? P is false. Not Q is false. P and so both are false. Good job. All right. If both are false, P and not Q is false. Let's see who's next. Maria, you want to try D, not P and not Q. P is false, not P becomes true. Q is true, not Q becomes false. A true statement and a false statement, right? If it's an and, that's false. You should see false without question mark. You're right, it's false. Okay. Michael, you want to try E? P implies Q. You think it's true? E is true, P implies Q. P says 4 is greater than 6. Q says 1 plus 1 equals 2, right? It is true. Right? It is true. Because Q stands alone. Because Q is true anyway. It does not depend on P in this case. All right, let's see. F. F, if, only if. Moises. False. Right, because Q and R, right? So this thing Q, if and only if R, which means 1 plus 1 equals 2, if and only if 1 plus 1 equals 3. Okay, obviously it's false. Okay, good job, guys. Oh, Ida is asking why is true. Why is E true? Hold on a second. Oh, why is E true? Okay. E is P implies Q. Remember, if P then Q, the condition, the truth table. If Q is true, P implies Q will be true. It doesn't depend on P. If P is true, Q is true, P implies Q is true. If P is false, however, Q is true, P implies Q also true. Does it make sense? Remember the wearing red, get $1 example? If you wear red, get $1, then you get $1, right? So that's if P then Q. But if you get $1, you get $1 anyway. So it doesn't matter if you wear red or blue, because you get $1 anyway. So the condition, it's like, we just ignore the condition. With the condition, then it's true, then it's true. Without condition, then it's true, the if then is also true. So which means it just ignore the condition. You feel better, Adan? Did I? Okay, just get used to that. It's just a logic. It is only false if the first statement is true. Moses, which one you're talking about? It is only false if the first statement is true, the second statement is false. You're right. Yes, you're right. But in the conditional statement, if the second one, the then part is false, then it doesn't matter the first one. The if then the implying is false. Good, good. All right. That's it. Okay, anybody has any questions? That's it for today. If no one has question, you know what? We're done for today. You can use the rest of 1 hour to do your homework. 2E. Okay, let's go back to 2E. Samuel, I was calling you earlier. 2E or 2D. 2D, not P and not Q. Okay, P is false, right? So not P becomes true. In the end statement, in the end, so for the command end to be true, the both statements have to be true or false. Okay, all right. So not P is a true statement, but not Q is a false statement. When we end a true statement and a false statement, that becomes a false statement. Make sense? Okay, that's in the truth table. Okay, anyone else has any question? Okay, if there's no, okay, let's see, Moses, it makes it easy to draw out the truth table. Yes, you know, in the beginning, logic, you know, the logicians in mathematics area, you know, are getting less and less logicians. You know, people like to do geometry, linear algebra, stuff like that, applied mathematics. But logic is more towards the pure mathematics realm. And so we're having less and less logicians in the world, unfortunately. Anyway, yeah, try to go through this, you know, classwork, because we already talked about, you know, we have answers for every question. Then try your homework. So logic at the beginning could be, you know, confusing, but once you get used to it, when you go to mathematical proofs, it's really helpful. Okay, anybody else has any questions? Okay, I know Maria is trying to catch up with homework. Patrick, you have a question?
No, but tomorrow I have to go to my office in the afternoon. So
Okay.
I'm either not gonna be in class or I'm gonna have to leave super early.
Okay, then you can watch the recording. I record every class.
All right, thank you.
You're welcome. Then, of course, you have to do the homework on
Yeah,
time.
I'll submit the homework before class.
Okay. Okay, Maria just submitted your homework. That's great. And anyone, and my Wu, I haven't received your homework yet. Can you tell me what's the reason you're missing your homework?
Yes, sorry. I was absent for the first day, so I didn't know how to submit.
Okay. Do you know now how to submit?
Would you mind going over it again?
Let me try to share the screen with you. So you go to, let's see, you go to course material, right? You see that's homework. So you have 10 homework in total. You click on this, it will pop up a session. You will see the homework itself, and you will submit through this this place. All right. Okay. Anybody else have questions? You probably don't have time to do the first homework and second homework anymore, because I'm going to post the second homework solutions later on. But focus on the rest of the 8, because there are still 8 homeworks. Okay, anybody else has questions?
Professor, I type my answers out on a Word document and then submit that. Is it okay?
It's okay. Any format is okay. As
Okay.
long as you submit through the CUNY Blackboard.
Okay, thank you.
You're welcome. Anybody else has any questions?
Yes, I have a question.
Yeah, Moises.
Do we get the solutions for the classwork or just the homework?
Oh, just the homework.
Okay.
Yeah, because the class one we're doing in class, and I don't have time to form all the answers for solutions for that. The homework, you'll have solutions.
Okay, thank you.
You're welcome. Homework 1, solution of homework 1 is already posted. Okay, anybody else has any question?
One last question. Can I just take a picture of my homework and send that?
Right, when you submit, right?
Mm-hmm.
Right, I think you have there are a couple of ways allow you to, as long as you can submit. It doesn't matter it's in what kind of file. Most people will take pictures, you know, send the pictures.
Okay, thank you.
You're welcome. Okay, but there's some different ways of doing that. All right, anybody else has any question? Okay, I'll see you tomorrow then, all right? Thank you. Thank you, see you tomorrow.